Ships carry routine cargo. Containers filled with manufactured goods, raw materials, commodities. But sometimes ships carry extraordinary cargo that requires specialized ships, specialized equipment, and extraordinary engineering. A ship has transported a 14,000-ton oil drilling rig across the Atlantic Ocean. A ship has carried the sections of a bridge that spans 2 kilometers. A ship has transported a submarine weighing 7,000 tons. A ship has carried an entire power plant. A ship has transported a space shuttle. These are not routine cargo operations. These are feats of engineering that require specialized heavy lift vessels, expert planning, and precise execution. The cargo shifts slightly and the ship might sink. The cargo is positioned wrong and the ship becomes unstable. The cargo is damaged and millions of dollars in value is lost. Understanding how ships transport these extraordinary cargoes reveals principles of engineering, logistics, and problem-solving under extreme constraints. Today we're exploring the strangest cargo ships have carried and how maritime engineers make the impossible possible. The Space Shuttle is perhaps the most remarkable cargo ever carried by a ship. The Space Shuttle orbiter, without its main fuel tank and booster rockets, weighs about 240,000 pounds. The orbiter is 122 feet long and 57 feet wide. It's extraordinarily valuable, weighing about $2,000 per pound. The orbiter cannot be damaged. When a space shuttle needed to be transported from one launch facility to another, it was loaded onto a specially modified barge. The barge was towed by tugboats. The operation required precise coordination. The barge had to navigate narrow channels and inland waterways. The orbiter sat on special supports that distributed its weight without putting concentrated loads on any single point. The center of gravity had to be perfectly positioned to prevent the barge from tipping. Large oil drilling rigs present similar challenges. An offshore drilling rig might weigh 10,000 to 20,000 tons. The rig has a large vertical footprint. If it's not positioned correctly on the ship becomes unstable. A heavy lift vessel used to transport drilling rigs has special features. The ship might have a moonpool, a large opening in the hull through which cargo can be loaded from below. The cargo is positioned low in the ship to lower the center of gravity. Ballast tanks can be controlled precisely to maintain stability as the cargo is loaded. The operation takes days or weeks. Bridge sections present unique challenges. A bridge built in a factory might be transported to the construction site by ship. A bridge section might be 300 meters long and weigh 10,000 tons. The section is impossibly long and narrow. If positioned on a regular cargo ship, it extends far beyond the ship's length and width. The section must be secured with hundreds of chains and cables. The bridge section acts like a sail in the wind. High winds could create forces that the securing cables cannot resist. The ship must operate in calm weather. The voyage must be planned to avoid storms. The operation is slow and careful. Submarines represent another class of unusual cargo. A large military submarine might weigh 7,000 tons. The submarine cannot be damaged because damage might make it unusable. The submarine is loaded into a heavy lift vessel using a semi-submersible ship. The heavy lift vessel can partially submerge itself. The submarine floats into position on the cargo deck. The heavy lift vessel then rises, taking the submarine out of the water. This loading method prevents damage from cables or lifting equipment. The submarine sits on the cargo deck as the heavy lift vessel crosses the ocean. Wind turbines have become increasingly common cargo for ships. A modern offshore wind turbine blade might be 80 meters long. The entire turbine, including the tower, rotor, and nacelle, might weigh 500 tons or more. Multiple turbines are transported on a single heavy lift vessel. The blades are distributed across the deck. Their distribution must be balanced to maintain stability. The narrow blades create wind resistance. High winds can create enormous forces. The ship must maintain stability and the cargo must remain secured. Wind turbine transport is a modern version of the ancient problem of shipping unusual cargo. Generator and transformer units for power plants present challenges because of their weight and fragility. A large power plant transformer might weigh 300 tons. The transformer is filled with oil that cools the transformer. The transformer cannot be tilted more than a certain angle or the internal cooling system becomes damaged. The transformer must be transported upright. A specialized ship might be required to carry a single transformer. The ship must maintain a level orientation. Any tilting beyond certain limits requires stopping and rebalancing the load. Heavy lift vessels used for extraordinary cargo are specialized ships. They are typically 150 to 200 meters long. They have a very large cargo deck. They have multiple cranes integrated into the ship structure. A single crane might have a lifting capacity of 600 tons. Multiple cranes can work together to lift even heavier cargo. Some heavy lift vessels have lifting capacities exceeding 1,000 tons. The crane systems can be controlled with precision to position cargo exactly. The ship has elaborate ballast systems that can maintain stability as cargo is loaded. The calculating center of gravity for unusual cargo is complex mathematics. The ship's stability depends on the position of the center of gravity. If the center of gravity is too high, the ship becomes unstable. If the center of gravity is too far forward or aft, the ship trims improperly. The stability calculations for unusual cargo require days or weeks of computer modeling. The cargo positioning is calculated to the centimeter. The ballast distribution is calculated to maintain stability throughout the loading process, throughout the voyage, and throughout the unloading process. Risk is substantial when transporting unusual cargo. The cargo might be worth hundreds of millions of dollars. If the cargo is damaged, the cost is enormous. If the ship sinks, the cost is catastrophic. Insurance companies charge high premiums for unusual cargo. The ship captains and crews receive special training. The route is planned to avoid storms. The cargo securing systems are inspected continuously. If anything appears wrong, the operation stops until the problem is diagnosed and corrected. Deck space on heavy lift vessels is optimized for securing cargo. Dozens of lashing points are built into the deck. Chain systems and wire rope systems are used to secure cargo. The securing systems must resist forces from multiple directions. Wind, waves, and ship motion all create forces that try to move the cargo. The securing systems must resist all these forces without fail. If the cargo shifts even slightly, the stability might be compromised. The entire load might shift, destabilizing the ship. The voyage planning for unusual cargo is meticulous. The route is analyzed for hazards. Narrow channels are avoided if possible. Weather forecasts are studied. If a storm is possible along the planned route, the route is changed. The voyage might take longer if it means avoiding bad weather. The speed is maintained within limits that minimize stress on the cargo. High-speed operation might create vibrations or impacts that stress the securing systems. Slower operation provides better safety margins. The cost of transporting unusual cargo is extraordinary. A single voyage might cost millions of dollars. A heavy lift vessel might rent for $100,000 to $200,000 per day. A complex operation might require the ship to be occupied for 30 to 60 days. The insurance cost, fuel cost, port fees, and crew costs all accumulate. The cost of transportation might be 10 to 20% of the total cost of the cargo. Only cargo that is extraordinarily valuable or extraordinarily important justifies the expense. Notable examples of unusual cargo include several famous cases. A power plant generator weighing 320 tons was transported from Japan to Turkey. A 570-ton transformer was transported from Germany to Brazil. A 1,000-ton modular factory building was transported from South Korea to Vietnam. A large drilling rig weighing 13,000 tons was transported across the Pacific Ocean. Each of these operations required specialized heavy lift vessels and took weeks to complete. Each operation was successful, but each represented the limit of what's possible in ocean transport. The engineering innovation in heavy lift vessels continues. Modern vessels have larger cranes and better ballast systems. Computer-controlled crane systems can position cargo with centimeter accuracy. Some experimental designs explore using floating vessels that can actually become submarines to load and unload cargo. Future heavy lift vessels might be able to transport even larger and more unusual cargo. Understanding how ships transport extraordinary cargo reveals principles of engineering and problem solving. The cargo cannot be changed, so the ship is modified. The route cannot be made shorter without increasing risk, so the route is accepted as is. The securing systems must work perfectly because failure is not an option. These constraints drive innovation in ship design, cargo handling equipment, and voyage planning. The result is an industry that can transport almost anything that can be imagined. If you're fascinated by how engineers solve seemingly impossible problems and how specialized vessels make remarkable feats possible, subscribe to the channel. We regularly explore how engineering innovation overcomes constraints. Understanding these operations reveals how human ingenuity finds solutions to extraordinary challenges. Your subscription supports the creation of content that explores how specialized industries solve unique problems. Thank you for watching and for your interest in understanding how ships transport the world's most extraordinary cargo.